This video is on the Pythagorean identities. There are three Pythagorean identities. Here they are. Sine of theta squared plus cosine of theta squared is equal to 1. Tangent of theta squared plus 1 equals secant of theta squared. 1 plus cotangent of theta squared is equal to cosecant of theta squared. So in this video, we're going to go over each of the identities and how to prove that they are actually true. So first, let's start off with this one right here. We'll call this the first Pythagorean identity. I want to go over some notation here. This exponent 2 right there is actually around the whole sine of theta. So this sine with the little 2 there and then the theta actually means sine of theta times sine of theta. They should really have this exponent around this whole piece right there, but they don't. But this is what it means. So that is equal to sine of theta times sine of theta. All right, so how can we prove that sine of theta squared plus cosine of theta squared is equal to 1? Before we get into that, let's quickly review trigonometry in a triangle. So the original way we defined sine was in a right triangle. It is equal to the, in a right triangle where theta is the angle for one of the corners, sine of that theta is equal to the length of the opposite side divided by the length of the hypotenuse. Cosine is equal to the length of the adjacent side divided by the length of the hypotenuse. And tangent was equal to the length of the opposite side divided by the length of the adjacent side. In another quick review, Pythagorean theorem, if you have a right triangle, the length of one side of the plus the length of the B side is equal to the length of the hypotenuse squared. So length of one side squared plus length of the other side squared is equal to length of the hypotenuse squared. Okay, so let's use these two ideas in a right triangle, the right triangle trigonometry and the Pythagorean theorem, to prove our Pythagorean identity. So first, let's start with this, our Pythagorean theorem in a right triangle, and let's put in those right triangle trigonometry words. So instead of calling this red side A, I'm just going to call the adjacent side. It is adjacent to this angle theta right there. And instead of B, I'm going to call this blue side the opposite side, opposite of this angle theta. And our green side is our hypotenuse, or our C. So just changing the letters A, B, C with these words right here. Okay, here the adjacent squared, the length adjacent squared plus the opposite side squared is equal to your hypotenuse squared. What I'm going to do is I'm going to, if I know this right here is equal to hypotenuse squared, I can divide both sides of the equal sign by hypotenuse squared. So that's what I did here. If I have these two terms divided by hypotenuse squared, I can split that into two different fractions. What I did here. All right, now let's take this. I'm going to copy and paste it onto our next page, and I'm going to start simplifying this. Okay, so it's right here. All right, let's simplify this. First thing I wanted to do is I'm going to split this into 2. I'm just getting rid of the exponents. So instead of adjacent squared divided by hypotenuse squared, I just wrote adjacent divided hypotenuse times adjacent divided hypotenuse. There's just 2 of them. Okay, now let's simplify this. If I can remind you from our previous review, adjacent divide hypotenuse is equal to cosine. So right here, where it says adjacent divide hypotenuse, this is the same as our cosine. So we have cosine times cosine. And opposite divide hypotenuse is equal to sine. So then we have cosine times cosine plus sine times sine is equal to hypotenuse divide hypotenuse, that's just 1, is equal to 1 times 1. Here we go. And just to clean this up, if you have cosine times cosine, that's cosine squared. Sine of theta times sine of theta is sine of theta squared, and obviously 1 times 1 is 1. So here you go. This is our first Pythagorean identity. This is true for all angles of theta, of any number, 55, 130, anything, any number. Let's now go on to our second Pythagorean identity. These next 2 Pythagorean identities are actually derived from this one. So we'll be starting off with this to create the other 2 Pythagorean identities. So Pythagorean identity number 2, tangent of theta squared plus 1 equals secant of theta squared. How do we prove that this is true? Like I said, let's start off with our first Pythagorean identity. And what I'm going to do here is I'm going to divide both of the sides. I know this right here is equal to 1. So that I can divide both of those by cosine of theta squared. Okay, and once again, I'm going to split this big fraction into 2 fractions, each of them having cosine of theta squared underneath. Now let's simplify this. This right here, because it has the same thing on the top and on the bottom, just simplifies to 1. 1 divided by cosine of theta squared. If you remember this thing called secant, secant is just 1 over cosine. So since I have 2 1 over cosines here, it just becomes secant of theta squared is equal to this. All right. Now this middle part, let's simplify this. So sine of theta squared divided by cosine of theta squared is what this fraction says, and I just wrote it here in one line. Now let's continue simplifying this. Reminder that sine is opposite divide hypotenuse. So sine of theta squared, well, that's just opposite squared divided by hypotenuse squared. Our cosine was adjacent divide hypotenuse, so same thing here. Now, how do you divide 2 fractions? You can turn the middle from divide into multiply, and then that second fraction just gets flipped, the reciprocal. So the adjacent goes to the bottom, hypotenuse goes to the top. Okay, let's continue simplifying that. Multiplying these 2 right here, your hypotenuse squared would cancel out with your hypotenuse squared. So this here and this will end up canceling out because this is times hypotenuse squared, and that fraction is divided by hypotenuse squared. So hypotenuse squared divided by hypotenuse squared just becomes 1. And then you have hypotenuse squared still on the top and adjacent squared, you have opposite squared still on the top and adjacent squared still on the bottom, which is right here. Okay, and reminder that opposite divide adjacent that we were talking about before, opposite divide adjacent is tangent. So your opposite squared divide adjacent squared becomes tangent squared. So finally, here is your second Pythagorean identity. 1 plus tangent of theta squared equals secant of theta squared. Right, and you do a similar thing in order to get our third Pythagorean identity. 1 plus cotangent of theta squared is equal to cosecant of theta squared. Okay, so let's start with our original Pythagorean identity. This time, I'm going to divide both sides of the equal sign by sine of theta squared. Once again, we're going to split this big fraction into two fractions. Okay, and let's take this into our next page. And let's simplify this. So 1 divided by sine is something called cosecant. So since this is 1 divided by sine of theta squared, it becomes cosecant of theta squared. Here, since we have sine squared divides sine squared, same thing on top and the bottom, that just becomes a 1. And now let's simplify this part. I'm going to change this into one line. Cosine divide sine, or cosine squared divides sine squared. So that's right there. And let's change this into those words, adjacent and hypotenuse again. Cosine is adjacent divide hypotenuse. Sine is opposite divide hypotenuse. Dividing the fractions, I'm going to change the divide to multiply, and once again, do the reciprocal of the second fraction, or turn the second fraction, like flip it. All right, and let's simplify this last line right here. To do that, once again, when I multiply my fractions, my hypotenuse squared on top and hypotenuse squares on the bottom will cancel, and you're just left with adjacent squared on top and opposite squared on the bottom. Adjacent divide opposite is cotangent. So cotangent of theta squared plus 1 equals cosecant of theta squared. This is your final Pythagorean identity. So, summary, here's your 3 Pythagorean identities. You don't necessarily need to know how they were created, but these 3 are true for basically any value of theta, as long as it's not undefined.